A pleasant day to everyone. Welcome once again to our session for today. So today will be our fifth part of our discussion on limits or limit of a function. So today we are going to focus our discussion on the infinite limits. Alright, so let us take this example here. We are given the limit of a function where our function of x is 1 divided by x minus 1 as x approaches to 1. Okay, now to prove that the limit exists, so we are going to do the same thing as in our previous lecture. So we are going to determine if the limit of the given function 1 over x minus 1 as x approaches 1 from the left. Okay, so from the left, which is represented by this expression. So the sign above 1 means that is the left hand limit. Okay, so let us determine if this limit exists. Okay, and then after that we are going to find also the limit of the function 1 over x minus 1 as x approaches to 1, but on the other side, that is coming from the right side. But before we go to that, let us review once again the number line system. No? So we have here our number line system, so assuming this is our 0 here. Okay, so we have here our 1, and we have here, say, 2. On the other side, assuming this is our negative 1, and assuming this is our negative 2. Okay, so if you look at this expression, limit of 1 divided by x minus 1 as x approaches to 1 from the left side. So it means that x approaching to this, okay, I'll change the color. So x is approaching to 1 from the left. Okay, so that is coming from the left. So what are the values that x will or can assume? So we have negative 2, negative 1, and so on and so forth until you reach positive 1. Okay, so if you examine, if you are going to substitute the values of possible values of x while it goes or approach to 1. So for example, if you take this number negative 2, so if you are going to substitute this number here, so we have when x equal to negative 2, so what will happen? We have minus 2 divided minus 2 minus 1 equal to minus 3, right? So negative. Okay, so if you take, for example, this value negative 1, so you have negative 1 minus 1, so negative 2. So 1 divided by negative 2, so your value is also negative. Or as you approach this value 0, so when x equal to 0, so you have 1 divided by 0 minus 1, which is minus 1, so the result is negative 1, so that's still negative. Okay, and as you go closer to 1, say for example you have here 1 half or 0.5, so when x equal to 0.5, so what will happen? So substitute this value to our function. So when this is 0.5, so 0.5 minus 1, so that is still negative 0.5, so you still have a negative value. Okay, and as the value goes closer and closer to 1, so what will happen, say for example, closer to 1 means say 0.99999, so your x now is 0.99999. Okay, so that's very close to 1. So when 0.99999 minus 1, so that is still negative. You have negative 0.00000001. Alright, so it means that we already know that the sign here will be negative. Okay, so now when the value approaches, or if you take the value equal to 1, so what will happen? X, which is equal to 1, 1 minus 1 equal to 0. So we have a denominator equal to 0. So we know that if you have 1 divided by 0, so what is the result? So this is a very huge number, right? Okay, so that huge number, because say for example, if you have 1 divided by say 10, that is point, what will happen? Sorry, 0.001. Okay, this is a very huge number. The result is very huge number, so we can call that as a infinity. So tends towards infinity. So that's why we have here infinity. So the sign here, the negative, is the one that we have discussed, that all the values taken by x from left going to 1 are negative. Even if the value is positive, but still when you substitute it here, like for example 0.5 for your x minus 1, so that will still give us a quotient that is a negative. Okay, so we have here a negative sign. Alright, now next we are going to determine the limit also for the function, but this time coming from the right. Okay, so next we have limit of 1 divided by x minus 1 as x approaches to 1, but this time coming from the right. Okay, so coming from the right. So the sign here, which is positive, so that indicates that our x can take the value from the right of 1. Okay, so the direction is right, so you have a lot of values from the right, so assume values for x going to 1, approaching 1. Okay, so all values are positive. So for example, if you say when x equal to 2, so this will be 2 minus 1 is 1, so 1 divided by 1 is 1. Okay, so if you have 2 divided by, so assuming our x here, x takes a value that is say x equal to 1, so when this is, or before 1, say here assuming 0.5, so you have 1 divided by 0.5 minus, okay, so 1, so x minus 1, so if this is 0.5, so this is, what will happen? This is also negative. Alright, is that correct? Negative, positive. So when x equal to, okay, so before we go to 1, so we have from here we have 1.5, no, 1.5, this is 1.5, so 1.5 minus 1, that is 0.5. Okay, so assuming this is our 0.5, so this is our 0.5, sorry, this is 1.5. This is 1.5. So coming from the right going to 1, so our values is decreasing. Okay, so perhaps we have started from 3, or we've started from 4, Okay, so when you substitute these values here, so for example, when x equal to 4, so 4 minus 1 is 3, so we have 1/3. When x equal to 3, so 3 minus 1, that is 2, so 1/2. Okay? And when x equal to 2, so 2 minus 1 is 1, so 1 over 1 is 1. When x equal to 1.5, so 1.5 minus 1, that is 0.5. So 1 divided by 0.5 is equal to 2, right? Or what is the value very close to 1? So the value very close to 1, so would be 1.5. Here we have 1 point something. So at the point where x is very close to 1, say at this point, so this could be something like, so from the right, should be greater than 1. So it should be 1 point, say 1.0, let's say 0.00001. Okay, very close to 1, but greater than 1. Okay, so assuming that this is the value that is very close to 1 coming from the right. Okay, so what will happen? So when you subtract, you have x, which is 1.00001 minus 1. So what is left is 0.00001. So now a very small number, and you have 1 at the numerator. So when 1 is divided by a very, very small number, that approaches to a very huge number. That's why we have here a positive infinity. So you have noticed that all values here coming from the right towards 1. So that is, we obtain the quotient equal to positive always. Okay, so that's why we have here a positive. So it means that both of the left hand, no, this is our left hand limit. So if you look at the left hand limit, so our left hand limit is equal to negative infinity. Then our right hand limit, that is also equal to infinity, but it's positive. Okay, so what can you say about the two limits? So the two limits exist, okay, negative infinity and positive infinity, but they are not equal. So therefore, the limit of 1 divided by x minus 1 as x approaches to 1 does not exist. Okay, so it does not exist. Alright, so I hope this is clear to you, class. Let's take another example. Or before we go to the next example, let us review first, no? What's really the nature or the behavior of our function, no, with infinite limit. So sometimes you will not be able to find a real number or a real number value for your f of x, because f of x increases or decreases without bound as x approaches to c. It means that as x approaches to c, the function increases. It becomes bigger and bigger, or becomes smaller and smaller without bound. There's no end. So we call this limit as infinite. So we call this infinite limits in this situation. Alright, so now we are going to discuss more about infinite limits. What is it? So if a function increases without bound as x approaches c, the limit of f of x is positive infinity. Or in symbol, so we have here positive infinity. Now, if the function f of x increases without bound as x approaches to c, the limit of the function f of x is positive infinity. On the other hand, if the function f of x decreases without bound as x approaches c, then the limit of the function f of x is negative infinity, or we have here a symbol, negative infinity. Okay, so just remember these two concepts. This is a very important ideas that we need, or we are going to apply now in our next discussion or next example. Then we have here what we call vertical asymptotes. So the line x equal to c is a vertical asymptote for the graph of function if, so these are the conditions, f of x approaches positive infinity or f of x or function of x approaches negative infinity. So we have here the line x equal to c. It can be x equal to 0, x equal to 1, or x equal to negative 1, and so on and so forth. So it depends. Alright? So these are the condition. So the line x equal to c is a vertical asymptote for the graph of a function if function of x approaches positive infinity or function of x approaches negative infinity as x approaches c. No? Plus here meaning from the right. Okay, here from the left. Okay, so don't forget this basic thing because this is a very small thing, but if you forget this one, it will create trouble when you're solving problems involving infinite limits. So remember this. Okay, so if that is plus, meaning coming from the right, the values of x or x can assume values from the right towards c. Here, from the left towards c. Okay, so in graph, so it's something like this. So we consider this as our vertical asymptote. This line here. Okay, this is the broken line. So this is what we call the vertical asymptote. Okay. So in this case, our vertical asymptote is equal to x equal to 1. Alright, so this is our y-axis. This is our x-axis. Okay, so this is our x-axis. And this is our y-axis, where y is a function of x, or y equals f of x. Okay, so you understand now what is vertical asymptote. So in this example, we have vertical asymptote is equal to x equal to 1. Okay, so next. Sometimes you're dealing with fractions, no? Fractions or rational expressions or rational functions. So after simplifications and the fraction is still of the form like this one, something divided by 0. So anything here, any number or any expressions divided by 0. So what is that equal to? So if we have that scenario, then we have the limit of the function of x as x approaches to c from the left. Okay, so from the left equal to positive infinity or negative infinity. So it depends on the given expression. Alright, or it can be the limit of, so for one side limit, the other one is the limit of a function x, limit of function x as x approaches to c from the right. So this can also be possibly positive infinity or negative infinity. Okay, so that depends upon the kind of function or graph that is given. Alright, so you have to take note that if this scenario happens, so for a limit to exist, one-sided limit should be equal. Alright, so we can say that the limit of the function exists. So we have to test whether the value of the limit for this limit of the function from the left and the limit of the function as x approaches to a certain value, in this case c, meaning from the right, both of them are equal. Otherwise, the limit does not exist. Now, it's related to our previous discussion. So it's just that this time we are having infinite limits. Okay, so next, so we have here evaluate and find the equation of the vertical asymptote. So we're given here a function that is 1 over x, and we're asked to determine the limit of this function 1 over x as x approaches to 0. So the same way, we have to find out the limit of this function 1 over x as x approaches to 0 from the left. Okay, so again, from our reference, okay, so this is our number line. So assuming this is our 0, so from the right, we have 1, we have, say, 2, then from the left, we have, say, negative 1, and we have negative 2, and so on and so forth. Okay, so what is the value of our function or limit of the function as x approaches to 0 from the left? Okay, so from the left, this is our reference. Okay, just hold on. So our c this time is, what is our c? So this is our c. That is the value that x approaches to, that is 0. Now, so considering this part, so it means our x assume values, negative values, and increasing negative values for x as x approaches to 0. So what will happen? So if you have, say, x when x equal to negative 2, so we have 1 over negative 2, so the result is negative. When this is negative 1, so 1 divided by negative 1, so when x equal to negative 1, so substitute it here, 1 divided by negative 1, so our quotient is also negative. Or what is this value that is very close to 0? What do you think? So we have 0.000001 negative, or negative 0.0001. Alright? So negative, so that's still 1 divided by 0.000001, that is negative, so that is still negative. So we can expect that the limit of the function 1 over x as x approaches to 0 from the left will be a negative. So when you have a number very close to 0, a very, very small number, so 1 divided by a very, very small number, which is negative, so the result would be a negative infinity. Okay? So a good illustration here is something like this. Okay, so when your x is equal to negative 0.1, when you substitute it here, 1 divided by negative 0.1, that is negative 10. If you have, say, 0.0001, substitute here, this is also negative, so you'll have negative 10,000. So if you go on adding zeros here before 1, so this will also increase the number of zeros, so it becomes bigger and bigger. Okay, and we have noticed that this is negative. Okay, so all the values from the left, if the reference, if the value of c is the number that is approached by x, negative, right? So you can expect a negative here, negative. So as the number, as x approaches to 0, the number getting bigger and bigger, okay, because the number here, as it get close to 0, it becomes bigger. So if you have, say, for example, 0.25 is bigger than negative 2. Okay, so for negative numbers, the closer that negative number to 0, so that the bigger that number is. But what we are talking here is values getting closer to 0, that is 0.000001, that is negative. Okay, so when you use that value here, when you substitute it here, so that becomes, the quotient becomes a very huge number, and that is negative. So we represent it as a negative infinity. Okay, so next we are going to find the limit of the function 1 over x as x approaches to 0 from the right. So this time, we are coming from the right. Okay, so coming from the right, going towards 0, approaching 0. Okay, so what are the numbers that x can take from? So we have negative 4, negative 3, positive 4, positive 3, positive 2, positive 1, and so on and so forth until it get close to 0. So what number very close to 0 from the right? So what is it? So if we have here 0.5, okay, so we have 0.2, 0.1, 0.0001. Okay, so it means if this value takes say a very small value, positive number, that is say 0.000001. So 1 divided by 0.00001 or 1 divided by a very, very small number, it will give us a very huge number. And we don't know how much is that. So we uh, represent that by what we call infinity. But this time, this is a positive infinity. So you see, the value of the limit L for this condition from the left right hand limit is negative infinity. Here for the right hand limit, this is positive infinity. So they are not equal. Both exist but not equal. So therefore, the limit of the function 1 over x as x approaches to 0 does not exist. Okay, so I hope you have understood this part of our lecture. So next, evaluate the following and find the equation of the vertical asymptote. Okay, so how about this? By the way, class, from the previous example, okay, so we'll take the second example for our illustration of the graph. Okay, so evaluate the following and find the equation of vertical asymptote. So we're given here 1 divided by x squared as x approaches to 0. Okay, so same thing, we are going to find the limit of the function as x approaches to 0 from the left and also from the right. Now for the function, limit of the function from the left, so our function is 1 over x squared. Okay, so 1 over x squared. So from the left. So again, using the the number line system. So assuming this is our 0. So we have 1 here. We have 2, 3, 4, and so on and so forth. And on the other side, we have negative 1, negative 2, negative 3, negative 4, and so on and so forth. Okay, so our reference here is our C is equal to 0. Okay, so as x approaches to 0. Alright, so taking this expression limit of 1 over x squared as x approaches to 0 from negative or from the left. Okay, using negative values here. So what's the result? So even if this is negative class, okay, so when x equal to negative 4, so negative 4 squared, that becomes positive, right? So it means that it's just similar to what we had in the previous slide. We have here approaches to 0 also, but this time the difference is that our x here is being squared. Okay, so whatever is the value here, when you square that one, that's always positive. So since we are coming from the left towards 0, so all the possible values for x are negative. So when you substitute it here, so negative, when you square that one, that becomes positive. So therefore, we can expect that the answer here is positive. Okay, so as the number becomes closer to 0, so what's the number closer to 0? That is negative. So almost 0. So we have negative 0.000001. Alright? So negative 0.00001. So 1 divided by 0.000001, a very small number. So when you square that one, that small number becomes much smaller. Okay? Now we have 1 divided by a very, very small number. So we can expect a very huge number, which we cannot determine. So we call that as infinity. But this time this is a positive infinity. Okay, so one example is something like this. If the value closer to 0, that is say negative 0.1. So when you substitute 1 divided by x, where x is being squared, so 0.1 negative, you square that one, so that becomes positive, but that becomes 0.01. No? We have 0.01 because it's just like you're multiplying 0.1 by another 0.1. So that's squared, so that becomes 100. So how much more if you are going to uh, take values very much closer to 0? So you have this. So when you square that one, that becomes a much smaller value. So 1 divided by that very small value, or something like this, when you square that one, when you divide it from 1, so you will get 100 million. So a very huge number. Okay, so that's our result here for the left hand limit. Now how about for the right hand limit? Okay, so for the right hand limit, so we are going to choose values for x, that is decreasing values for x. Okay, decreasing, say you can take value for x equal to 4, you substitute it here, so 4 squared, 16, 1 over 16, then you have 3, so 3 squared, so 1 over 3 squared, or 1 over 9, and so on. Okay, until you reach a very small value here. So our x value is decreasing towards 0. Alright, so assuming you have 0.1. So 0.1, if the value of x is 0.1, so 0.1, we have 1 divided by 0.1, you square that 1. So you will get, again, positive 100. Or if you have 0.0001, then you square that 1, you divide it from 1, so you get this 100 million. So you see, we have same result, positive infinity as well. So since the limit, the right hand, the left hand limit and the right hand limit both exist and are equal, so therefore we can say that the limit of the function 1 over x squared as x approaches to 0 exists, and the value of that is infinity, which is positive. Okay, so I hope that's clear. Now let's move on to the next slide. So this time we have another theorem. Okay, so the theorem here, this is based on the result of what we had discussed just a while ago. So we have here a limit of 1 over x to the power n as x approaches to 0 from the right side. That is, or that will give us a positive result, which is infinity. Okay, so that is coming from the right side. So if it approaches to 0, if you have this kind of expression 1 over x to the n, so we have a positive infinity. And for the left hand limit, if you have limit of 1 over x to the power 1 over x to the power n as x approaches to 0 from the left. Okay, so this time we are coming from the left. So we have two possible values here. So the result for this, it's either positive infinity or negative infinity, depends on the situation. It's positive infinity if n is even. No? This n here, if this is even. So what is even? We have 2, 4, 6, 8, and so on and so forth. Otherwise, we have negative infinity. So if n is odd, then the result of this is negative infinity. So remember this theorem, class. We are going to use this in our coming examples. So now we have rules involving infinite limits. So what are these rules? Okay, so we have sum. So we have a scenario that you possibly have a sum of some expression that involves limits, infinite limits. So sum involving infinite limits. So we have here L, meaning L stands for the limit, plus infinity. So if you have obtained the limit, then you add that with positive infinity, then the overall result is positive infinity. So there's no bearing, right, this value here. So whatever it is, when you add it with a very huge number, so this is just a very insignificant value. So that's why it yields positive infinity. Like for example, if you have 1 billion plus 1, so 1 billion plus 1 is just like 1 billion. So the one there doesn't have a very huge effect to the huge number. Okay, so that is what is meant by this rule. Okay, and if you have L minus infinity, just imagine you have 1 minus 1 billion. Okay, so it's just like it has no significant effect. So that's why we take the here negative infinity. So if you encounter this uh, situation where you are subtracting a certain number or certain value by infinity, so the result here is negative infinity. Okay, now for the product involving infinite limits. So product involving infinite limits, so this is the scenario. We have limit multiplied by positive infinity, so the result would be positive infinity. It means that a very huge number, you multiply it with any number or any value, that makes the number more or much bigger. For example, you have uh, 1 million. Your limit is 2. So 2 times 1 million, so that becomes 2 million. It means that it becomes much bigger. So we cannot determine what value is that. So that's why we represent it by infinity. Okay? So this is positive infinity. And we also have limit multiplied by negative infinity. So rule of multiplication, positive multiplied by negative, the product would be negative. Alright? And we also have the quotient rule involving infinite limits. So what is the rule there? So if you have, say, positive divided by positive, so what would be the quotient, the sign of the quotient? So this would be positive also. Right? Now if you have negative value divided by another negative value, so the result would also be positive negative. So this is positive. So in other words, if you have a fractional expression having the same sign, numerator and denominator have the same sign, whether it's plus or negative, but they are the same. So the quotient is positive. Like for example, if this is negative numerator, denominator is negative, so when you divide, the result will also be positive. And of course, if you're dividing numbers of different signs, the quotient would be negative. So if you have, say, plus divided by minus, so plus divided by minus, so the result would be minus or negative. Or if you have negative divided by positive, so you will have negative quotient as well. Okay, so that's the rule, no? Involving quotient, a quotient involving infinite limits. All right, so let's move on. So we have here evaluate limit of 2 plus 1 divided by x squared as x approaches to 0. Okay, so we know that when x approaches to 0, so when you substitute this is 0, or a number very close to 0, so what number is that? So it depends now. You have to look at the right, if it's coming from the right or coming from the left. But as you evaluate this one using the rules that we have just learned, so you see, so 2, we know that 1 divided by a very small number, you square that very small number, that becomes, and then divide it from 1, so 1 divided by a very small number, that becomes huge number, so we represent this by positive infinity. Okay, so roll limit L plus infinity, so what is the result? That is positive infinity. Okay, so that is what is meant by L plus infinity, which is equal to infinity, positive. Okay, so if you grab this, you can find the vertical asymptote. Oh, what is that vertical asymptote? That is the value of x that can make the denominator equal to 0. So in this case, what makes the denominator equal to 0? That is 0. So therefore, your vertical asymptote is x equal to 0, or simply the y-axis. So this is our y-axis, or yes, this is a y-axis, this is our x-axis. Alright? So x equal to 0, that is equivalent to y-axis. Next, right, so we have our next number. What is the limit of the quantity 1 divided by x plus 1 plus 5 divided by x cubed as x approaches to 0? Okay, so using the rule, so we have 1 because as x approaches to 0, so this becomes 0. So 1 divided by 1, that is 1. So that is our first term. Okay, then plus, what is 5 divided by 0. So 0's cube, that is still 0. So any number divided by 0 is a very huge, or a number very close to 0 is a very huge number. So that is infinity, or that does not exist. So we have 1 plus that infinity or does not exist. So we have DNA, or does not exist. Or you can say this is a plus infinity, and this is our infinity. Okay, so this is plus, so you can use this plus. Alright, so this indicates a very huge number which does not exist. Okay, so what is the vertical asymptote? So the vertical asymptote is the value of x that can make the denominator equal to 0. So in this case, we have two values that can make the denominator equal to 0. So this is negative 1 and we have 0. Okay, so therefore, if you graph this one, okay, so when you tabulate, assume values for x, solve for f of x, so this is our f of x. So this will be the graph that you will see. Okay, this is the kind of graph that you will see. So vertical asymptote here, we have x equal to minus 1. So, okay, this is our vertical asymptote, x equal to minus 1. This is our origin, 0, 0. This is the intersection of the x-axis and the y-axis. This is our x-axis. This is our y-axis here. Okay, so the intersection of x and y-axis here, that is the origin, 0, 0. So from here towards this, that is equal to minus 1. So you have the vertical asymptote equal to minus 1. And we also have, take note, this is the vertical asymptote for this part of the graph here. And we have another graph, part of the graph is here. So the other vertical asymptote is x equal to 0. So this one. So x equal to 0, which is the y-axis x equal to 0 is equivalent to y-axis. Alright? So we have two vertical asymptotes here. Okay. So once again, I hope that you have understood this part class. Then how about this? So here we have okay, so we take the same expression. So we take the limit from the left side. Okay, so from the left side, if you look at the graph, you see here, from the left side, approaching 0. So our 0 is here. Okay, this is our 0. This is the origin. So okay, so our x takes the values from the left towards x equal to 0. Okay, so x equal to 0 is y-axis. So it can take these negative values here. Alright, so negative values. So it means that if you substitute negative values here, of course, if you have negative 1 here, for example, so negative, for example, if it reaches to 0 already, so we have 1 divided by 0 plus 1, so that is 1 over 1, that is equivalent to 1. And if you take x, okay, so plus, you have our x here, all the x are negative, so we can expect a negative quotient here. Alright, so as x approaches to 0, meaning a value very close to 0, say for example, from the left. So what is the number very close to 0 from the left? That is negative, also negative 0.000001. Okay, so when 5 divided by 0.000001, then cube that one. So that number is a very small number, and when you cube that one, the more that it becomes very small. So 5 divided by a very small number, so that is a very huge number, and we cannot determine that one. This doesn't exist, so we can represent that as infinity. Alright, so the negative here indicates that all the values, or the values that is closer to 0 coming from the left, is negative. So that's why we have a negative here. So from the rule that if you add a certain number by infinity, so the infinity will prevail. So this would be negative infinity. Okay, so 1 here doesn't have a significant effect. It's a very huge number, but negative. Alright, so next, if you take the vertical asymptote, so this is our vertical asymptote here. Okay, so what makes the value, the denominator, equal to 0? So when this is negative 1, right? So that's why we have this vertical asymptote here at negative 1, because this makes the fraction when this is 1, so negative 1, so this becomes 0. This makes the denominator equal to 0. So that value of x that can make the denominator equal to 0, that would be the vertical asymptote. So in that case, we have x equal to minus 1. So that's why we have here vertical asymptote, this blue color here, vertical, x equal to 1, negative 1, sorry. Okay, the other vertical asymptote is when x equal to 0. So this becomes 0. So 5 over 0, 0 squared, that is still 0. Sorry, cube. 0 cube, that is still 0. So 5 divided by 0, or a very small number. So that makes a very huge number. So in terms of asymptote, vertical asymptote, so x equal to 0 would be another vertical asymptote. Okay, so this is another vertical asymptote here, this one. Alright, now for another example, we have limit of the quantity 5 minus x divided by x cubed multiplied by another quantity 4 minus x divided by x squared plus 1 as x approaches to 0 from the left. Approaches from 0 from the left. So take note from our division of fractions rule. So we have plus divided by minus, so you will get a negative result. Okay, so from the left, so 0, so the same as in our previous example. Now we have here the vertical line, the number line. This is our 0, this is our 1 here, this is our negative 1, negative 2, and so on and so forth. And x approaches to 0, so we are referring to this number here, which is 0. Okay, so from the left, okay, all values from the left going towards 0, approaches 0. Okay, so we can expect that this is negative. If this is negative, you cube that one, that is still negative. Okay, so negative, so if this is negative, you square that one positive, but still, since this is multiplied by negative, you will get a negative result. Okay, so now if you have a very small number, okay, you square that one, a very small number, so you have, say for example, x is close to 0. What value close to 0? We can have negative point from the left, negative 0.000001. Okay, you cube that one, that becomes much even smaller. Okay, so 5 minus that 0.00001, so that becomes, what will happen? Minus, tapos negative, so this becomes plus, so this becomes 5 point something, right? Okay, so 5 point something divided by a very small number, so the overall result becomes infinity. Okay, so similarly for this part, 4 minus a negative number, so this becomes 4 point something. So square this one, a very small number, so more or less this is 1.00001. Okay, so a very small number. Okay, so the overall result, no, is negative infinity. So here is negative infinity. Here we have something 4 minus a very small number. Say 4, this becomes minus minus, so 4.0001. So here we have 1, or say 0.00001, you square that 1, then plus 1, so that becomes 1.000001, so almost 1. So that's why we have here 4. So the 4 here is just an approximate of what we obtained when you substitute the value of x, that is very close to 0. So in 4 minus a negative number closer to 0, so this is almost 4 also. This one, very small number, you square that one, that becomes even more, much smaller. So 1 plus that very small number, so almost 1. So it's just like you are dividing 4 by 1. So 4 divided by 1, that is equal to 4. So in the rule of multiplication, limits involving infinity, so when you multiply it, so a huge number, negative, multiplied it by a very small number, so what will happen? Like for example, if you have 1 million multiplied by 4, so that becomes still million, 4 million, negative. Alright, so the result here would be negative infinity. Okay, so what is the vertical asymptote? The vertical asymptote is the value for x that can make the denominator equal to 0. Okay, so when this is 0, so this becomes something above divided by 0. Okay, so this is 0, even if this is not 0, because the rule of multiplication of fraction, you have to multiply the numerators, you have to multiply the denominators. So this is 0, multiplied mo by anything here, so the overall denominator, the product of the denominators, equal to 0. Okay, you have something at the numerator, but you divide it by the denominator, the product of denominators, which is 0. So something, which is at the numerator, 0 at the denominator. So therefore, the value for x that can make the denominator equal to 0, that would be the asymptote. So we have therefore here the asymptote, that is vertical asymptote, that is x equal to 0. So this line here. Okay, x equal to 0. So this is the vertical asymptote. Alright? Okay, so this is our vertical asymptote, x equal to 0. Okay, so another example, we have limit of the quantity x plus 1 divided by x squared plus x minus 6 as x approaches to 2 from the right. Okay, so from the right. So coming from the right. Okay, so let's draw our number line for reference. So assuming this is our 0, so we have 1, we have 2, we have 3, we have 4, and so on and so forth. On the left side, we have negative 1, negative 2, and so on and so forth. Okay, so our C here, meaning the value of x that is being approached, is 2. Alright, here. And then we have plus. So it means coming from the right. So we are concerned of the right hand limit. Okay. So what is now the limit? Is it positive or negative infinity? So that's the question now. Okay, so let us check. Let me erase this one so that you can see it clearly. Okay, so we have here as x approaches to 2, so we can substitute the value 2, for example. So we have 2 squared plus 2 minus 6, so 2 squared 4 plus 2 6 minus 6, so that makes 3 divided by 0. So numerator 2 plus 1 is 3. The denominator, when you evaluate, when you substitute the value of x equal to 2, so that becomes 0. So the question now is it positive or it's negative? So take note that coming from the left. Okay? So coming from the coming from the right, this is plus. So coming from the right, so it means you can assume values closer to 2. Okay, I will redraw this number line. So we have here the number line. If you have this 0, you have 1, 2, 3, 4, and so on and so forth. So we are so our C means the value of x, or the values of C that x approaches to is equal to 2, and we are coming from the right. Okay, coming from the right towards 2. Okay, so it means that very close to 2, it's not 1.999 because 1.999 is coming from the left, but we are given here plus, so coming from the right, so it means very close to 2, so that is 2 point something, right? So you can say points 2.001. Okay, so when you substitute 2.0 x equal to 2.001, so plus 1. Okay, so we have here, instead of 2, we use 2.0001 for our x. You square that one. plus this one, and so on and so forth. So you will see that you have positive at the numerator, the denominator is also positive, so we can expect the quotient that is also positive. So this time we have, when you square this one, this is 4 point something, right? And when you add it, this 4 point something to this 2 point something, that is 6.0000 something, then minus that 6. So what is left is that very small value, and you have the numerator 3.001 divided by a very small number. So we'll get a very huge quotient which cannot be defined or does not exist, so we call it infinity. Okay, so this is positive infinity. All right, so the vertical asymptote. So to solve for the vertical asymptote, since the rule is to determine what makes the denominator, or what value of x that can make the denominator equal to 0. So from the denominator, we have here a quadratic equation. So by quadratic equation, you can solve for x here and set each factor to 0. So you can factor this one. What are the factors of x squared? And x squared plus x minus 6. So factor of x squared is x and x. Factors of 6 is 3 and 2, or 1 and 6. Then we have here positive. This is negative 6. So negative 6 has factors like negative 3, positive 2, or positive 3, negative 2. Alright, so since we have positive here, so we take the bigger value of the factor, which is 3. Factor of 6, which is 3, positive, the other one is negative. So therefore we have x plus 3 times x minus 2 equal to 0. Setting its factor to 0, so we have x equal to minus 3 and x equal to positive 2. So these are the vertical asymptotes. Okay, so these are the vertical asymptotes. Alright, so if you draw this one, so we have two asymptotes here, the vertical asymptotes, that is x equal to minus 3 and x equal to positive 2. So these are the asymptotes, vertical asymptotes. Okay, so this represents x equal to 3, this line here. And the other one is this one, x equal to 2. Okay. Next, we have x squared plus 4 divided by, or the limit of the quantity x squared plus 4 divided by x minus 1 as x approaches to 1 from the left. So sorry, this should be above. No, this should be here from the left. So what's the limit? Is it positive infinity or negative infinity? Okay, so let us see. Again, if you draw the number line, so it's always a good thing, class, to refer it to the number line system. Alright, so since it's coming from the left, now if you're going to draw the number line again, so that you will understand why those values come up like that. Okay, so assuming this is our 0, we have here 1, 2, we have negative 1 here, negative 2, and so on and so forth. Okay, so x approaches to 1. Okay, so this is our 1. And coming from the left, because of this negative, coming from the left. So it means these are the values of x. These are the values that x can take going to 1. Okay, so the question now is it positive or negative? So you see here, all the values are negative, right? or even if not negative, because we have here x minus 1. So in other words, if the values is very close to 1, so what value that is very close to 1? Coming from the left. So it should not be like the other example that we have 2.001. The 2.001 coming from the right, but this one coming from the left. So it means that, so what is this value here, for example? So it's not equal to 1, right? So that could be 0.99999, right? It could be 0.99999. So therefore, using that value, so if you are going to substitute, okay, so the question now is the limit positive infinity or negative infinity? So with that illustration here, so we know that x will take a negative number and also positive number. So for example, when x equal to minus 2, so minus 2 minus 1, so that is minus 3. So we have numerator divided by numerator is positive, because when you square negative 2, that becomes positive. Okay, here we have negative minus negative, so that's negative. So you have positive and negative. So therefore, the quotient is negative. Now, if for example the value of x very close to, say for example, we start with 0.5 here. So when x equal to 0.5, okay, so if x equal to 0.5, that's close to 1 but not very close. So let's take this value for example. Okay, so when you substitute it here, so negative 0.5 squared, so that is positive. Then 0.5 minus 1, so that is negative 0.5. So that is still negative. So you have positive at the numerator, negative at the denominator. So that gives us a negative quotient. Okay, so if you have, say, 0.9999 like this, okay, so at the numerator you substitute 0.999 squared, then plus 4, okay, so 0.9999 minus 1, so that is still negative. So that is negative 0.00001. So positive at the numerator, negative at the denominator, so we can expect the quotient as negative. Okay, so we have positive, negative, therefore it will give us a negative. So infinity, because the denominator here is a very small value, because 0.9999 minus 1, that becomes negative 0.0000001. So a number here at the numerator divide by a very small number, 0.0000001. So that is a very huge number which we cannot determine, or we just represent that as infinity. And the sign here, since the numerator is positive, the denominator is negative, so we have a negative infinity. Alright, so I hope it's clear. So now let's find out what is the vertical asymptote. So to find the vertical asymptote, you just look at the denominator. What makes the denominator equal to 0? So what is the value of x that can make the whole denominator equal to 0? So in this case, when x equal to 1, so 1 minus 1 equal to 0. So therefore, our x equal to 1 would be our vertical asymptote. Okay, so this is our illustration. Our x equal to 1, so this is our x-axis. Okay, here this is our x-axis, and this is our y-axis. So this is the origin. Alright, this is the origin, the intersection between x and y-axis. This is the origin. So we have x equal to 1. So x equal to 1, this is our x equal to 1 at this point here. So draw a vertical line. Okay, so that would be the vertical asymptote, x equal to 1, the red color one. Alright, so another example, limit of the quantity x minus 1 divided by x plus 5 as x approaches to negative 5 from the left. So negative 5 from the left. So if you're going to once again draw the number line system, okay, so assuming this is our 0, This is -1, -2, -3, -4, -5, -6, and -7, and so on and so forth. Okay, so the value of x, or the value that x approaches to, is -5. So this is our -5. Alright, so coming from the left. Okay, so x can take values from the left going to -5. Okay, so for example, what values for x? You can take, say, for example, -6. So if this is -6, or shall we say -7, -7 plus 5, so this is -2. Okay, so negative, this is negative, -7 minus 1, so -8. So this is -7 plus 5, so -2. So we have negative at the numerator, negative at the denominator, so that would be positive, right? So we have plus the numerator, assuming our x equal to -7. So our denominator is also plus. Sorry, negative. This is negative. So the numerator is negative, the denominator is negative, so you have the overall result as positive. Okay, so for example, when x equal to -6, so when x equal to -6, so take this value here. Okay, substitute it here. So -6 minus 1, so -7. So numerator is negative. So -6 plus 5 is -1. So minus the same as here. So you will still have a positive result. Okay, how about when the value very close to 5, say for example -5.5. Oh, sorry, 6. So yes, -5.5. Substitute it here. So negative. So that is still negative. So negative divided by negative, positive. Or when the values is very close to -5, like for example -0.499999. That's negative. -0.499999. So this becomes positive, right? Because 5 is bigger than -4.9999. So the denominator now becomes positive, but what happens to the numerator? This is 4.99999 negative, so negative, negative. So what's the result? Positive, negative. Okay, so in short, so what is the sign of the infinity here? Positive or negative? Okay, so this is the, so, or the values that is very close to -5 from the left. So this is a negative 5.0001, right? So 5.001, because we are moving to the right, but if you look at the values, this is 5. So the value that is the left side of 5, it's a growing number, but it's negative. That's why we have here negative, sorry, 0.0001. Okay, so this number is, if this is for example uh, assuming this is our 5, okay, 5 negative. If you have here at this point here, this is something like 5 point, say 5 point, it can be our 5.001, okay, because as you go to the left, if you go to the left, right, this becomes 6, so this is negative, this is negative, okay. So it means the 5 point, the one that I mentioned a while ago, 4.999, is not, this should be on the other side, but since 5 is the reference, so it should be on the left side. So the left side will contain 5 point something that is negative. Okay, so that's why we have here negative 0.0001 plus 1, so that becomes 4.001. So here, and this is negative, and here 5.001 negative plus 5, that is 0.0001. So negative also, we have negative at the numerator, negative at the denominator. So that's why we have the overall result as positive. So again, certain number at the numerator and at the denominator a very, very small number. So that gives us an infinity, a very huge number. Okay, so that's positive. Negative divided by negative, that's positive. So the answer here is positive infinity. Alright, so I will erase this part here just to give you a second view. Okay, so this is the direct substitution for x equal to 5. Okay, so this becomes minus 5 minus 1 minus 6 minus 5 plus 5, 0. Okay, so minus 6 something divided by 0, or minus 6 divided by 0, that is undefined, does not exist, and we represent that as infinity. Okay, and we use this value to get uh, a glimpse of what is the overall result of this. So we have 5, negative 5.001 plus 1, so this is negative. Yeah, this is also negative because this one is greater than 5, so you have negative and negative, so negative divided by negative, you have positive, so positive infinity. So what's now the vertical asymptote? So the vertical asymptote is the value of x that can make the denominator equal to 0. So in this case, when x equal to minus 5, so that makes the denominator equal to 0. So therefore, the vertical asymptote is equal to x equal to minus 5. Alright? So when you graph the function, so this is the picture of that function when you graph it. Okay, so vertical asymptote is minus 5, so it means this is our minus 5 here, x equal to minus 5. This is our x-axis. Okay, and then this is our y-axis here. This is our y-axis, and the intersection between the x and y-axis, this is what we call origin. Okay, so from here you count 1, 2, 3, 4, 5. So that is where our vertical asymptote is located. So this is the line, vertical line, x equal to minus 5. Okay, so I hope you're still following. Now, next two slides, we have finding here the vertical asymptotes. If you're given this kind of expression or function, y equal to x plus 1 divided by quantity x minus 1, then cube. Okay, so how to solve for the vertical asymptote? So just look at the value of x that can make the denominator equal to 0. So in this case, we have in x equal to 1. So 1 minus 1, that becomes 0. 0 raised to the power 3, that is still 0. So you have x plus 1, or your x is 1, so 1 plus 1 is 2. 2 divided by 0. Okay, so that makes undefined. So that value that makes the function undefined is the vertical asymptote. So in this case, we have the vertical asymptote x equal to 1. Okay, so I think last one. So we have another given here. Function y equal to x squared minus 2x minus 3 divided by x squared minus 4x plus 3. So we are asked to find the vertical asymptote. Okay, so here, if you look at the numerator, this is factorable. So you do factoring here as well as the denominator. So by factoring, you can see that there is a common factor at the numerator and the denominator. Okay, so x minus 3 divided by x minus 3, that is equal to 1. Alright, so what is left is x plus 1 divided by x minus 1. So now you can easily see what is the vertical asymptote. So what makes the denominator equal to 0? So when x equal to 1, so 1 minus 1 equal to 0. That makes the denominator equal to 0. So therefore the vertical asymptote is x equal to 1. So as illustrated in our graph here, okay, so x equal to 1. So this is our vertical asymptote. So what is asymptote, class? That is the line that the function, the graph of a function will get closer and closer to but will never touch. Okay, but in our illustration it touches, but in reality it will never touch. Okay, so I think that's all for today, and thank you for listening, and I hope you were able to follow all our discussions, and uh, we'll see you again in our next um, presentation, or part 6. So we'll talk about in that topic about continuity, discontinuity. Okay, so thank you very much, everyone. Have a pleasant day to all of you, and stay safe and healthy always. God bless. Bye bye.